Okay, so we are doing variation. You have learned direct variation, and I think you might have learned inverse variation, but I don't fully remember, so don't quote me. But I know you've learned direct variation. Do y'all remember learning proportional? When things are proportional? You learn it in 8th grade. You also learn it again in Algebra 1. Proportional just means that it goes through the origin and it's a straight line. Yes? Okay, so direct variation is proportional, unless it's like a combination. Okay, if it's straight direct variation, then it's proportional. But if it's combination like the second one or some of the other ones, then it's not proportional. But so K is your constant of variation. You can also call it your proportionality. Okay, that's V. 90% of the time you'll see constant of variation, but you could also see it called constant of proportionality. So just know that those are the same thing. Really, that's all you need to know. There are 4 different types of equations here, meaning there's 4 different ways to find K. So we're going to find those 4 different ways and we're going to write them down. So first way, there it is y equals kx. So if we know y equals kx, how would we get K by itself? No, we're not going to subtract because this is multiplying, so we're going to divide. Divide both sides by x, and we get K equals y over x. So we know that this is my equation, and this is how I find my constant. Constant. Dang it, I cannot write. That's a T, I promise. So this is my equation. This is how I find my constant of variation. So K equals y over x. This is not your equation. This is just how you find your K to plug into your equation. Does that make sense? Okay, so knowing that, if we keep reading, it says, suppose y varies directly as x. That's just telling me, we're in direct variation right now. That's telling me that I'm using direct variation. Okay, direct variation is telling me y equals kx. That's if it starts with y. So see how it says y first, y varies directly as x, which just means kx. So if y is 5 when x is 30, so y is 5 when x is 30, find the constant of variation in the direct variation equation, and then find these things. So this is 1, and this is 1. So what I use those first 2 numbers for is to help me find K. It always has to give me 1 point. So that's like a point. It gave me the point 30, 5, right? Y is 5, x is 30. And I'm going to use that to find my K. Well, I know y divided by K, so 5 divided by 30. And if I type that in my calculator, 5 over 30, I get 1/6. So I know K is 1/6. Therefore, my direct variation equation, I'm just going to plug K in, is y equals 1/6 x. Everybody okay with that? Okay, there are 2 ways to find the next 2 answers. It says find y when x is 24. Well, you know the equation. Can you type it in your y equals? Yes. Okay, go to our table. We're looking for when x is 24. And what do I get? Y is 4. So do y'all know that trick where you can do second window and it says table start and you can type your x value? Okay, if you don't, that's fine. You could have just scrolled. However, but when you're looking for where y is -1, you can't do anything fancy like that. You actually have to just scroll and find it. So these are all positive, so I need to go up to find negatives. And there's y is -1, so what does x equal? So that's one way to do them. However, could you also solve them pretty simply by hand? Yes. So you know that y equals 1/6 x, but x is 24. Well, you could literally type 1/6 times 24 gives you 4. There's your answer. Yes? Here, you knew that y is -1 equals 1/6 x. How do you get rid of a fraction when multiplying? Can you multiply by the reciprocal? Yes, which is just the flip of the fraction. What's this fraction flipped? 6 over 1, which is just 6. So you can multiply both sides by 6. And that cancels this, and you get x equals -6. So there's your answer. So you can do it by hand, you can do them in the calculator. I do not care whichever way you do them. You could do it either way, and you get the right answer. Yes? Okay. Sometimes with the bigger numbers, it's easier to do it by hand, just strictly because you don't want to scroll forever. But if you are okay with scrolling forever, that's fine. You do you. Does that make sense? Okay. This second one is technically a combined variation, but it goes with direct variation, so I left it here. I want you to know that it says suppose y varies directly as x, but it says as the square of x. So we're still using the direct variation equation, except x is squared this time, because it tells me the square of x. Yes? So I still find my constant the same way, except what's x? Squared. So everything's the same except x is squared on both of them. Do you see the difference? That's the only difference. Okay, so knowing that, it says if y is 24 when x is 2, so y is 24 when x is 2, which x is squared, so 2 squared. Well, that gives me 24 over 4, which equals 6. So what does k equal? 6. So my equation is y equals 6x squared. Now, do you rather do them by hand, or would you rather do them in the calculator? Okay, so 6x squared. Second graph, we're looking for where x is -2. What's my y? 24. And then I have when x is 6. Well, what I want you to notice is there's x is 6 twice. Because this is quadratic, if you hit x, because it's squared, it's a u. So it happens twice, so x is -1 and x is +1. If you were to have solved that one by hand, the first one's super simple. Y equals 6 -2 squared, which would, if you typed in your calculator, would have told you 24, end of story. Super simple. Yes? The second one, you would have done 6 equals 6x squared. Divide by 6, divide by 6, and you get x squared equals 1. How to get rid of a squared? Square root. And when you square root both sides, y'all, when you take the square root of a whole number, don't you have to put that plus and minus in the front? Don't know if you remember that, but that's why it's both. So you could have gotten the same thing both ways. So the big difference here was, again, it was direct variation, it told us that, and then it said square of x. Okay, the next one is inverse variation. So the inverse is the opposite. Instead of multiplying by x, what is it doing? Dividing. So that's the only difference here. It's y equals k over x. So if we had to find k, to get k by itself, what would I do? Multiply both sides by x, and I get k equals x times y. So k equals x times y is how I would find my constant here. So this is my equation, and this is my constant, my k equals. So knowing that, it says suppose y varies inversely as x, which is my equation, if y is 3 when x is 5. Well, what's 5 times 3? So k is 15. Now I will tell you, sometimes these numbers for the inverse variation will get pretty big, and that's okay, because you're multiplying to find them. So if you have larger numbers for x and y, you're going to have larger constant of variation. So don't stress out if you see something a couple hundred or whatever. It's going to happen. So my equation is what? Well, k is 15 over x. So once I know that, you can do it in the calculator, or you can do it by hand. Either way, it says find y when x is -5. I'm going to show y'all mostly by hand from here on out, just strictly because y'all should know how to do it in the calculator if that's your preference. If you prefer to do it by hand, that's the different part, so I'm going to do that by hand. Y equals 15 over -5. What's 15 divided by -5? And the next one says find x when y is 3. Well, 3 equals 15 over x. Y'all, the easiest way to solve this is technically you'd have to multiply both sides and then divide, or you can just cross multiply and divide. It's the same concept. 15 times 1, I just made 3 over 1 a fraction. And I get 15 equals 3 times x is 3x. Now what? Divide both sides by 3, and what do you get? So pretty simple to solve by hand. Yes? Any questions so far? Okay, one thing before we flip is I want you to realize that all of these had y first. And that's why they were y equals equations. Do y'all see that? Y varies, y varies, y varies. Yes? Look at the next example. So this is joint variation. The equation is different. And if it read y varies jointly, not jointly, jointly, this is the equation you would use. But what does my example say? It says x varies jointly. So it's going to be an x equals equation. However, the formula is going to be the same. I'm just kind of flip-flopping some letters. So I still have my k, and I'm still just multiplying. Well, what are the letters after jointly? YZ. So it's just YZ. That's all it comes after. Now, this one you cannot do in the calculator because you have two variables. Okay? But 9 times out of 10, it's super simple to solve, so don't stress over it. But to find k, what would I have to do to get rid of YZ? Divide by YZ, divide by YZ. So k equals x over YZ. So every single time k is going to be not usually x over YZ. What's it usually going to be? Like, what would it be here? Y over XZ. So for your normal formula with y varies, it would be that. If you notice, though, we flip-flopped our x and y, so we flip-flopped our x and y. Okay, so knowing that, we're going to plug in our numbers. If x is 50, when y is 2, and z is 4, well, that's just 50 over 8. And if we simplify that in our calculator, thank you. Okay, that gives me 25 over 4. So k is 25 over 4. Therefore, my equation is x equals 25 over 4 yz. I kind of wrote it on the line because I wrote really close to the line. And then it says find x when y is 6 and z is 10. Well, the nice thing is I'm solving for x and it's x equals. So this is going to be a calculator problem. X equals 25 over 4. YZ, well, what's y? 6, and what's z? So literally I can type that in my calculator. And I get 375. Yes. I just simplified. Huh? Well, 2 times 4 is 8, so 50 over 8, which they're both even, so cut them both in half, you get 25 over 4, and it doesn't simplify further than that. Because there's nothing in common. So you could even type in your calculator, look, 50 over 8, and it just simplifies to 25 over 4. That's the simplest it gets. Okay, last one. This is the one. Don't let this one lose you. Okay, combined variation is many different forms. Most likely you're going to see direct and inverse, which is like our practice problem. Okay, combined just means what it sounds like. You're putting two of the other variations together. Yes? Okay, so if you read, this is your normal formula when it says y varies whatever, okay? But what do we have first? Z. So we have z varies directly. Well, if you look at our direct variation equation, you don't have to flip with me. Direct variation is when we have k times whatever's after. So y varies directly as x, so we had k times x, right? So this one tells me varies directly with x. So we have z equals k x. And inversely, what did inversely tell me to do? It told me to divide, right? That's when I was dividing by whatever was after. So when it said it varies inversely as x, we divided by x. See that? So if it tells me inversely with the square of y, what's going to go on the bottom? Not x. The x is on top. There was no x after the words, so it's just y squared. So these are the ones that you have to read super careful. This is more of an example versus a formula you're going to use every time. Okay? The other 2 or 3, those are formulas you use every time. This is more of an example, because what if it said y varies jointly? This is not what you would use. You would have x, y, or you had k, x, z on top. Okay? So knowing that, we have to find k. How do I solve for k? Well, I have to get rid of the divide by y squared, so I'm going to multiply both sides by y squared. And I have kx equals zy squared. What do I do now? I'm trying to get k by itself. What am I getting rid of? X. I need to divide both sides by x. So this is my k. So knowing that, I'm going to use those 3 numbers they gave me. Z is 18. Y is 2, but y is squared over x is 6. And that's going to give me my k. And I get 12. So my equation is z equals 12x over y squared. And it says find z, and we have 12, when x is 8, well, x goes on top with my k, and y is 9, and that's 9 squared because y is squared. I type that in my calculator and I'm done. And I get 32 over 27. Okay, so don't let these stress you out. There's 2 things I do want to tell you on your review, your practice. You can write your k equations above, so k equals y over x, k equals x times y, k equals y over xz, and then remember, this is your example, this one's the weird one. So this depends on your problem. Okay, so that's just kind of your cheat to find your constant. Now you'll notice all of them say y varies, y varies, y varies, y varies, y varies, y varies. So those are all y equals until you get to number 7. It says x varies. So what kind of equation is that going to be? X equals. Whatever letter's first is what it equals, right? That letter equals. So the nice thing is 1 through 6 are going to be completely normal with y equals equations. They're going to follow those formulas at top. Yes? And then number 8 is a word problem that we didn't really talk about, but it's going to be a bonus, an extra 10 points.